Section 5.4 is about properties of midsegments. So in this section, you're going to learn what a midsegment is and how it applies to two shapes. We'll look at triangles and trapezoids. So first, there's a review. Find x in the trapezoid below. There's a couple different ways that you can actually solve for this. So one way is it's a four-sided figure. So you know there's 360 degrees in a four-sided figure. So you can add up all the angles. We have 90 plus 90, which is 180. If we add up all the x's here, we have, 5x? And then combine like terms, negative 17 plus 2 is negative 15. All right, so here's one way we can set up this equation right here and solve for x. So we could start by combining like terms, the 180 and the negative 15. So we get 360 equals 165 plus 5x. Subtract 165 from each side. We'll get, I believe it's 195 equals 5x. And the last step will be to divide each side by 5. So x is 39. All right, we'll start with the definition. A midsegment is the segment containing the midpoints of two sides of a triangle or connecting the midpoints of two non-parallel sides of a trapezoid. So they show you a picture. The blue line here is the midsegment of the triangle. These two lines are equal or congruent, and these two lines are equal or congruent, so it's the midpoint of each side. And here's the midsegment of a trapezoid. Again, it's formed by connecting the two midpoints of the trapezoid. So those are midsegments, the middle of either the triangle or the trapezoid formed by connecting the midpoints. We'll do an investigation in class where we'll discover a couple different properties. But basically, if you connect the midpoint of each side of the triangle, then the three midsegments of a triangle divided into, and the answer here is 4 congruent triangles. You can see from the picture here that the 4 triangles are exactly the same. So that's the triangle midsegment conjecture. So we'll be using that property. Another investigation is we're going to use this triangle and measure the segments in cm. All right, so right here, this is an example of connecting all the midpoints of each segment. And that will lead us to our next conjecture. The midsegment of a triangle, is blank to the third side and blank the length of blank. Let me break it down because that picture has a lot of midsegments. If I just draw a triangle and a midsegment, so let's say I make my midsegment the middle of this side right here, and the middle of this side right here. Let's say this is my midsegment right here. This midsegment is parallel to the third side of the triangle. So it's parallel to this side. And half the length of the third side. Okay, so what would that look like? Well, it's parallel to the third side and half the length of the third side. So if this side was 10, for example, this side would be half, this side would be 5. So that's the special property of a midsegment of a triangle. It is half the length of the third side and also parallel to the third side. We can look at the midsegment of a trapezoid. So that was a triangle. Here's a trapezoid. And this conjecture says the midsegment of a trapezoid is parallel, so again it's parallel, to the bases, and remember the bases are the two congruent sides of the trapezoid, so it's parallel to the bases, and is equal in length to the average of the two bases. Okay, so how do we solve a problem like that? Let's say we wanted this midsegment, the length right here. I'm going to call that x. So first of all, it's parallel to these two, the bases. And to solve, it's the average of the two bases. So to find average, remember you add up the numbers, divide by how many there are. So we would do 12 plus 8 and divide that in half. That would give us 20 divided by 2. So the average of those two bases is 10. So the mid-segment is 10. Let's do one more example. So let's say I had a trapezoid that looked like this. And let's say this was the mid-segment. So there's the mid-segment. And let's say that this shorter side was, I don't know, 10. And this longer side was, how about 16? How would we find this mid-segment right here? Well, you find the average. So again, you add them up and divide by 2. So we get 26 divided by 2. So x would be 13. So it's the average of the two bases right there. Okay. Let's practice using these three properties. So again, you have the trapezoid mid-segment conjecture where it's parallel and equal to the bases and equal to the average of the two bases. We have the triangle mid-segment, which is half of the third base and also parallel. And then we have the four congruent triangles conjecture. So let's practice using those. Here's similar problems right here. And each figure shows a mid-segment. So solve for A, B, and C. All right, so if this is a mid-segment, these are parallel. And we can start by using properties of a triangle. To find angle C, this is like the outside angle. If you remember, it's equal to the sum of the two remote interior angles. So we can add 54 plus 37. And that will be 91 degrees. So angle C is 91 degrees. All right, also we have parallel lines and a transversal here. So we have corresponding angles that are equal. So B is 54 degrees, they're corresponding. And angle A then, there's a couple different ways that we can figure out angle A. I'm going to look at this whole triangle right here. I know there's 180 degrees in a triangle, so we can do 180 minus 37 minus angle B, which is 54. And that will give us angle A, and that ends up being 89 degrees. Okay, we have another triangle mid-segment. We know that Y is going to be half of 14, so that's going to be 7. We know that this is a mid-segment, so X is also 21. Z is going to be 16 plus 16, which is 32. So this is 21, 32.